So good evening, all of you. Welcome to the second live session. We already had an informal interaction 1 week before for this NPTEL course on multi-core computer architecture. It's a pleasure to see a couple of you coming today evening. I know it's a working day and majority of you are students studying for undergraduate degrees or postgraduate degrees. Some of you may be faculty members as well. Some are from industry. It's good to see a good number of enthusiastic people are actually attending this course. So we are just completing the first month of the course. It is a 3-month long course, which spanning across 12 weeks. And then I request you to make use of this live session. We have already posted forms in the announcements, but then if you have any query that has been coming, we can have 2 modes. Either you can raise your hand if that option is available, and then we will call you one by one. But if you wish to post your queries, you can also post it in the chat box. We will be happy to take up these queries. Our backend team consisting of Rajeshwari, Vivekananda, and Abir will coordinate these queries. Okay. So there are 2 modes. Either you raise your hand, I will call the name, and then you unmute and speak, or you can post your query. It would be good if you start with the query, let's say which lecture number or which broader topic the query belongs to, so that if at all I need to take up any slide, then that will help me in quickly locating the slide. Okay. So our slide numbers are numbered as 1A, 1B, 2A, 2B, 3A, 3B, like that. So that will be little easy for me in locating the slide and then going. If you want a description with the slide. Anyhow, now we are on to the 7th and 8th week slowly moving. 6th week almost completed. And then looking at the way how people are actively participating in the assignments, I feel some of you are very actively learning, and some of you may be little struggling as we move into advanced topics, but please do visit the videos multiple times and then look at the assignments. Sometimes you may not be able to complete the assignments with full satisfaction, but then we have also providing a detailed solution to the assignment. In that way, it will be helpful for you. And then towards the end, we'll have discussion on the final exam as well. Some of you have already registered for the exam, which has been scheduled in October last week. Okay, with this background, let me open it up for students to post their queries. So like as I mentioned, 2 ways. Either you raise your hand, then we'll call up the name, or else you can post the queries in the chat box. And from our backend team will type the queries to me, and then I will be able to answer to these queries. Over to the participants.
Sir, you're on mute. We can't hear you.
Okay. Chetan, you have raised your hand. Maybe Chetan Somana can unmute and ask the queries.
This is regarding the Thomas-Ull's algorithm. So basically this in week 4, 3E. And then the page number is 25 in the slide.
Okay.
So basically,
so you want me to describe, it's 3E, right?
Correct. And page 25 is a slide.
Okay.
So basically, I haven't understood how to take the source operand. Like, should it be CDB or should it be ROB? Like, I'm a little confused. Like,
which is this slide number?
3E.
Slide number or page?
Page 25. Yeah, PE, page 25.
Okay, page 25. Okay, I'm just taking. Let me share my slide.
Yep.
Can you see the slide?
Correct, yes.
Yeah. So tell me in which instruction number you face the problem first.
I don't remember it much, but what I have thought of is like if there is a functional unit which is waiting for the instruction, should it be coming from the CDB or ROB? Like, I mean, at which instance should it be CDB and at which instance should it be ROB?
Okay, Chetan, very good. So just for the understanding of other students who have not understood this question, what Chetan is asking is, this is a table where for various instruction, we are trying to find out at what cycle instruction is issued, that you can see, and the issue column. And then there are two source operands, operand 1 and operand 2. And from where do you get the value of the operand? So if RF stands for, I am directly taking from register file. CDB means I'm getting from bus directly. And ROB means I am taking from the ROB. So Chetan's question is, how do you identify, should I get from CDB or should I get from ROB? So there are, let me try to make it very clear. So let's look at the very first instruction, division instruction. The first operand R4 is destination, and the source operand is one is R4 and other one is immediate operand 12. Since it's the very first instruction, R4 value is available in register file. And in the second instruction also, R6 and R12 as the source operands, both are available in the register file. And the third one, you can see that it's a division operation with R1 and R2. So R1 is never used. So R1 is directly taken from register file. Whereas R2, you are going to get the R2 not from register file. So how do you get it as CDB? The answer is, you are going to issue at cycle number 3. At cycle number 3, you know that the value of R2 is not available. But where is R2 available? R2 would be available from the output of multiplier. When will multiplier produce the result? At cycle number 7. So you have to wait till cycle number 7. At cycle number 7, the result of multiplication would be broadcasted through the CDB. So you can take it from CDB. So the answer is CDB because at cycle number 3, the value is not available in ROB. ROB, the value is available in ROB only after cycle number 7. So from 7 to 12, it is in ROB. So when the issue happens before 7, I have to wait in CDB because the value has not even reached ROB. But if I happen to do the issue after cycle number 7, then I have to take it from ROB. That is the difference. So Chetan, did you understand that?
Yep, my query is resolved now. Yep, that was my question.
Okay. So it basically depends upon when you issue, look at the issue time. At the issue time, whether the result that you are looking forward, has it reached ROB? If it has not reached ROB, when will you reach ROB? After write back. So at cycle number 7 onwards, you will get the value in ROB. So if your issue happens at cycle number 7, then you are from CDB. But if the issue is at cycle number 8 onwards anytime, it is in ROB. But if the issue happens after 12, in this case, that second instruction is committing at 12, so it would be in the register file. So if in the RF. Hope I am clear.
Yes, you are clear. Yes.
Okay. So any other query anyone has? So Amal, you can unmute and speak.
Hello, sir. Like you said, there is three types of hazard, data hazards, like read after write, write after write, and my question is why there is not a read after read hazard.
Okay. So this question that has been asked, so I think I can stop sharing now. That slide is now no longer relevant. So Amal, if you look into, there is no problem as far as when you are trying to read two instructions. Let us say I wanted to read add R1, R2, R3. Consider the first instruction. Consider the second instruction, add R4, R5, and R6. Now, let us say you are going to read this one and imagine that the first and second has the same operand. So add R1, R2, R3, add R4, R2, and R3. Now, whether the first instruction happen or second instruction happen, it is not going to create any trouble because R2 and R3 are my source operands. Whether the first instruction read me first or second instruction read the source operand first, it is not going to create any problem as far as the output of the instruction is concerned. The problem happens when one is writing and other one is either reading or writing. So the writing means it will change the value. So when you have a changed value and someone else is going to read it, whether it has read it before the writing or after the writing, the value that I am reading is going to be different. So So that makes the difference. So when two people read after write is never going to become a hazard because there is no value update.
Okay, sir. Thank you.
So Chirag Joshi, please ask your query.
Yes, sir. Sir, am I audible?
Yes, Chirag.
Yeah. So, sir, my doubt was like when we look the product specification of model multi-core processor architecture, they're like written 4-core, 8 threads, and you taught like there can be multiple threads. Like so, my doubt is thread a physical thing on processor or like uh uh it's an issue of instructions? Like I wanted to know that.
Yeah. So Chirag, there are two aspects for it. One is called software multi-threading and second one is called hardware multi-threading. So hardware multi-threading is possible only if the hardware has additional features which will support issue and execution of two set of instructions. Let us say I am going to open two tabs of a browser. So the browser is the program and tab 1 is one thread and tab 2 is another thread. So they all share some common space, common instructions. That's what the outside window of the tab, the close button, everything. So when you do multi-threading, the hardware essentially should have some features wherein I can switch from one thread to another. So a single core multi-thread means hardware have the facility such that I can stop fetching and decoding and executing of one thread and I can context switch into the other one. That is called a multi-threading facility. Multi-core is totally different. Multi-core is duplication of hardware resources. Whatever that pipeline that you learned, imagine there are 10 such parallel pipelines. So you can run 10 separate programs. So that is what we will learn from the 8th week onwards when we introduce tiled chip multi-core processor. That's why the title of the course itself is multi-core computer architecture. So in short, threading, there are two ways in which you can do threading. One is process level threading, process and threads. So these are multiple aspects of the program. And then it can be done at the hardware level. So when you have multiple threading, is multi-threading possible only if the underlying hardware supports context switching between threads. So if hardware doesn't have a multi-threading feature, then I cannot switch between multiple threads. Our conventional old processors don't have such a kind of this threading facility. Am I clear, Chirag?
Yes, understood.
Okay. Anybody else? Any query? Please raise hands. So there is a question in the chat box. That's what I am seeing now. Okay, there is a brief journey about processor from 8085 to multi-core RISC processor like MIPS. So if you look into, initially processors were designed like you have an ALU and you have a control unit and you have a memory. And from there you fetch the instructions and decode and execute. They were not pipelined. So initially 8085 is you fetch, decode and execute. After the execution only you go to the next instruction. Then you have the sequence of 8085 moving to 8086 where you have broadly two-stage pipeline. The bus interface unit or the fetch unit and the second one is the execution unit. So everything fetching will be done in the first stage and decoding and execution happens in the second stage. Then you have the sequence of processors from Pentium 286, 386, 486, Pentium Pro and all, wherein more deeper pipelines were introduced, memory protection was introduced, and then people were looking at instruction level parallelism by adopting advanced pipelines, handling of hazards, structural hazards, data hazard and control hazard, later introducing branch predictors. And then people came to know that over the period of years, we have reached a maximum level of instruction level parallelism and we are not able to improve the CPI value, not able to reduce the CPI value, cycles per instruction beyond a limit. And that led to the idea of why are we only bothering about one instruction pipeline? Can't we have multiple instruction pipeline? So can you duplicate the resources? That led to the idea of having multiple processors, in short, multiple instruction pipelines with supported cache memories, your private L1 caches, and then working upon a shared main memory. This led to the idea of multi-core processors. So we are going to learn about this multi-core processors from the 8th week onwards. So that's the sequence, and then Ashik Kapoor can even read about the journey of microprocessor evolution from 4004 or from 8085 to modern multi-core processors. Okay, so Rajeshwari, I am seeing one question by Asta, so you need not copy back into the thread. I can read it from the chat window. So in the meantime, let me try to clarify Shubham's query. Shubham, you can speak. I will come back to the doubt mentioned by Asta on branch history table. I'll come to it. Yes, Shubham.
Yes, am I audible?
Yes, yes.
Yeah, thank you for this live interaction session. And coming to the question, so like I have been working for embedded applications now, but till now before this course, basically I have been working on one single core only. So any kind of a TI or STM microcontrollers I have worked. So while taking the course, like some clarity I still seek on some aspects like multi-threading and multi-core, just as you were mentioning in the previous query. So if I have multi-threading, can that be implemented on single core?
Yes. The answer is yes.
Okay.
So Shubham,
that-
what you have to understand is there is a core, which is an instruction pipeline, which you are going to fetch, decode, and execute. Now, multi-threading means there are two lightweight processes. Two programs are there, but they are part of the same program. That's what I told. For easy to understand, let us imagine a browser. I'm opening a Google Chrome, and I'm opening one tab wherein you are, let's say, opening your Gmail. The another tab is, let's say, you are opening Facebook. So both are two threads. These two separate tabs are two threads from a software perspective under one process. So what is the process? The browser. Google Chrome is the process. It has two tabs. These are threads. Okay. Or else, if I tell you, let us say you are going to type it on a Word document. So this Word document is the process, and based upon what you type, new characters are coming on the screen. So taking the character from the keyboard and displaying it on the screen, that is one thread. At the same time, let's say the spell checker is working. So what happens parallelly, the moment you type, you can see that whether it's a blue line or the grammar mistake, the typos it is going to show. So in short, what it happens is there are two threads. One is reading a character from keyboard and then printing on the screen. Second one, parallelly doing the spell check or grammar check. This is working together. In short, we have only one hardware, one instruction pipeline. So what will I do? I fetch, decode, and execute the spell checker program, which has a sequence of instructions, maybe within a for loop, continuously checking whether that's correct, checking with dictionary or not, and the other program wherein you are typing. So it is basically two set of instructions. But what I have to do, let's say the first set of instruction is running in 2000 onwards in memory. The second thread is running, the threads program is stored in 5000 onwards. So two threads, one stored in 2000 in memory, second one stored in 5000 in memory. Now, if you see, I am fetching from 2000, 2001, 2002 for some time. Then I switch to 5000, 5002, 5003 sometime. The switching is so fast that the user will not be able to know one program stopped.
Yeah. Okay.
Okay.
So essentially, these are a kind of, as you said, that one program is a complete frame. In that, two threads or multiple threads are running.
Threads that you are running.
But essentially,
so the overhead involved in switching from one thread to another is very minimal than you switching from Facebook to WhatsApp. They are two independent programs. They are not multi-threaded. Are you able to get what I am telling? The status field and the chat window of WhatsApp, they are two threads, which is within the WhatsApp framework. So switching from your chat to the calls to the status, it is switching between threads. But switching from WhatsApp to Facebook, two different programs that you continuously run, that is multi-threading. That is multi-processing.
Processing.
So underlying hardware should have the capability for this switching. When I come back, I should resume from where I stopped. The hardware should have some extra features. That is multi-threading, but only one processing cores. But multi-core means I am duplicating the resource. Everything that you have, make.
physical entity itself, I have resources extra so that I can process different
That is multi-core.
process. Yeah. Okay.
And even multi-core can be multi-threaded. Each core can have support that multi-threading.
Yeah. Okay. Clear. So coming to multi-core, multi-core essentially means GPU, or as as you explained currently, like if multiple, suppose if I arrange in a hardware level, I have multiple cores arranged in such a way on the board that, okay, I can execute multiple programs on those. So
it is not about
multi-core
GPU.
essentially,
Whatever you learned in instruction pipeline, imagine you have 4 such instruction pipelines. Okay. And then you have a hardware unit, which suppose imagine you have 4 programs, WhatsApp program, Facebook program, your Teams program, like that 4 different programs stored from 1000 onwards, 2000, 3000 and 4000. Now in multi-core, what happens is you have separate program counter for each of the instruction pipeline. One program counter will keep on updating and fetch program from 1000 onwards. That's your WhatsApp program. And it will feed into instruction pipeline number 1. The second one parallelly will fetch. It has a separate data bus and address bus, which will fetch from location 2000 onwards. Third one will fetch into. So it is like 4 working units. All are fed with instructions by separate fetch units. So it's just like duplicating everything that you learned till now, till cache memory. Whatever that you learned, have multiple copies of it.
Okay.
That is multi-core.
Okay. Yeah, that clarifies a lot. So basically, GPU is like at scale. Many bits as taken in the lecture also. Like for example, we have many pixels, data manipulation and all going on. So this is at large scale. Specific physical entities are working to update and execute all the instructions that is performing manipulation of data.
GPU is an example of a multi-core device. Now the question is, you have many, let's say hundreds of simple units. Units capable of adding and multiplying. Simple units, maybe 100 of them. All these 100 units may not be CPUs, which can fetch, decode, and execute. These are only units which are capable of performing, let's say, an integer multiplication or floating point multiplication. It don't have fetching facility. They are simply execution units. Your EX stage, your floating point EX units. You learned about A1, A2, A3, M1, M2, M3. Imagine such units, a composite A1, A2, M1, M2 division unit. Let us say you arrange 10 rows and 10 columns of such units only. That means parallelly I can do 100 floating point operations. It cannot fetch.
Okay, understood.
Okay, that is GPU. Understood. It is multi-core. What is there in each core? Each core is a sophisticated functional unit. That's all. Now, CPU means it has fetch, decode, and execute by itself. But I cannot go for 100 because a CPU will be taking this much space because it is fetching, decoding, executing everything. So only 4 or 5 is possible in the available chip. Whereas GPU is very small, its functionality is very limited, so that I can have more. So what I am going to tell is, let us say in a playground, you arrange 100 nano cars, 10 rows and 10 columns. That is GPU. You can organize maybe 10 luxury buses. That is a multi-core CPU. It is more functionality, capability. The available space is limited, but nano car has very limited capability. But I can keep more of them. Okay, that is GPU. The other one is a multi-core CPU.
That clarifies. Thank you.
Okay.
Thank you.
Okay. Let me see. There is a question. Until now, I find difficulty to understand the concept of hardware-based dynamic approaches. So, what should I do? This question is asked by Tushar. Tushar, generally, multi-core processors, its understanding, dynamic scheduling are little hard. Only 5% people would be able to understand, those who study computer architecture. I took it more than 1 month to study it during my undergraduate or postgraduate days. Don't feel bad about it. The idea is when you have a compiler-based approach, your compiler rearranges instructions, and when you supply to hardware, hardware need not bother at all. Hardware just need to run them. All hazards, possible hazards of two instruction I1 and I2 coming together, they are being sufficiently separated by compiler. That's what compiler-based scheduling. So then compiler need to understand the hardware and accordingly you have to put it. But when it comes to dynamic scheduling, I am not seeking the help of compiler. Compiler can be from any other company. I don't really care. You give the instruction in whatever way that you want. But the problem is there can be dependencies between instructions. When I try to run out of order, let us say I have 5 functional units. My first instruction is an add, but adder is busy. Second instruction is a multiplier, but multiplier is free and it is not dependent on the adding. So can I run them? That is called out of order. So what it has been taught in the slide is how can you have a hardware setup where raw, var and wow hazards are taken care of. How can you permit certain instruction to start execution even before its previous instruction is not yet fetched or completed? So you require some extra hardware units. So that is why in Tomasulo's algorithm, you have the concept of reservation stations. You have the concept of dividing your ID into issue and read operands. And then ultimately you have something like a reorder buffer so that you can do speculation. So the only thing is you read through that slide 1 or 2 times, listen to the video 1 or 2 times, and then trying to understand what is a bigger picture of this. You could also read Hennessy and Patterson textbook of dynamic scheduling. That will also help us. Okay. So Tushar, that I hope that gives you a little bit more help. But if still you find any issue, I can help you by a one-to-one learning. You can write to me in my email on a Saturday or Sunday. Maybe I can describe this whole process once again with the help of a slide. So Sandeep Chatterjee, thanks for the feedback since you are able to love of course. If Sandeep would like to speak, you can unmute and speak, Sandeep. Are you a student or are you somewhere working in a company? If Sandeep is online, you can speak.
Yes, sir. I am an MTech student and I just joined your course this session, and I'm finding it very useful, sir.
Okay. So, do you have any doubt or query?
No, not for now, sir.
Okay. Thank you. So let me now go through the question by Asta. So if Asta, if you are online, if you could speak, it would help me in understanding what this query is. So Asta, is it possible for you to unmute and speak? You have already shared it in the chat box. So I saw that slide, what it is. Branch history, I understood that. So if you could make it more easy for me by telling it out, I will be able to help you better.
Hello, sir. Can you hear me?
Yes, Asta, go ahead.
Like my doubt is, suppose we have 10 branch instructions in a program, then we are saying that we are recording, say, let's say 3 branch, is 3 of the previous branch histories we are recording for better prediction. So my doubt is, like, suppose when we are executing 4th branch instruction, then we are taking into account the history of first 3 branch instructions. When we are executing the 5th one, then we are taking account of 2nd, 3rd, and 4th branch instruction. And similarly, when we are executing 10th branch instruction, in that case, we are taking into account 6th, 7th, and 6th, 7th, and.
I got it. Okay. Tell me, what is your doubt?
So means my doubt is, like you mentioned, branch history table is a table and not a register. So to me, it seems it should be just a register and not a table. So I thought there is some disconnect between my understanding and your delivery. That I thought it is. My understanding told me that it should be a register.
No.
It is specific
so I will
to
tell
each
you.
branch.
So Asta, what you are understanding, there is a small disconnect. I will tell you. See, when you have, let us say, 10 branches in a program, and imagine some of the branches are repeating. Let us say you are inside a for loop. So the for loop will take multiple times. So there is an instruction which will tell you, based on a condition, repeat the loop. Okay. That equivalent machine instruction is your branch. Are you able to get? Now, this instruction will run, let's say, 100 times if the for loop is 100 times. What we learned in our branch prediction is, based on the previous outcome of the for loop, can I predict what will happen to the for loop in the current iteration? It is not dependent on some other instruction. So you are thinking that every branch is dependent on previous branch. No. Every branch is predicted generally based upon the outcome of the previous iteration of the same branch. That is what we learned with the help of an example. Okay. Now, each of these branches, so for loop, let us say there are 5 for loops, one after another. So I have 5 different branches. Okay. Now, each of the branch will repeat multiple times. So when I come to the first iteration of the for loop, I don't have any background history. When I come to the second iteration of the same first for loop, I can predict what happened in the last iteration. Will it impact my current iteration? So what you store in branch history table is every branch, there will be an entry. What we discussed in our numerical problem is we are assuming there is only one branch. And what are we looking at? We are looking at the past occurrences of the same branch, whether past was taken or not taken, past 2 occurrences, past 3 occurrences. Based upon the past occurrence of the same branch, I am trying to predict what will happen to this branch now. Okay. So there in the problem, if you are trying to work out, you can see that there are 4 rows. That is, there are 4 entries, TT, TN, NN, TT. This is for the same branch. Okay. And then what we are trying to work out, how for the subsequent iteration of the same branch, how the states are changing. So those 4 things indicate 4 rows in a table in the real branch predictor. Imagine there are 2 branches, branch 1 and branch 2. So branch 2 also there may be another set of rows. So what you saw in the table is only for one branch. If there are multiple branches, that many number of rows get added. Okay. And how do you get, what is the role of PC? Because different branches are stored in different memory addresses. So how do you distinguish these branches? This you will make use of the program counter also. That's all.
Okay.
Hope you got the clarification.
Yes.
Yeah. Okay.
Thank you. Thank you, sir.
Yeah. So there is a question by Bhanu Prakash about what are open source tools that are used today in computer architecture research. So Bhanu Prakash, what we use in our laboratory by my own PhD students, especially when you work in CPU, GPU, CPU, cache memory and interconnects, we use Gem5 tool, Gem5 and Garnet. It's a very open source tool that is being used. People use Sniper, that's another popular tool. Some people even use some tool known as Chamsin. So these are all architectural simulators that is being used. Okay, so that answers Bhanu Prakash's question. Gem5 is the one that we are using in our laboratory. There is a question from Chirag Joshi. Advanced research in the field done by private organizations like Intel, AMD and NVIDIA. Do these companies publish their research for general public? Yes, of course. If you look at top computer architecture conferences like ISCA, International Symposium on Computer Architecture, then HPCA, High Performance Computer Architecture, then Micro, then we have VLSI Design, this generally happens in India, DAC, Design Automation Conference, DATE, Design Automation and Test in Europe Conference, and then there are many such conferences which are in this field. We get research papers from academia as well as from industry. 20 to 30% papers are from Intel, AMD, Qualcomm, these companies. But then you can read these papers, only the abstract is, if you wanted to download these papers, you may have to do it either through your college. It requires an institutional subscription because the copyright is with either IEEE or ACM. So these companies are really making, some of them they patent, but they do both the things. Sometimes they publish for publishing conferences and then sometimes when something is really coming to the product, they may not publish, they may go for a patent once the product is ready. So companies do in both ways. Some of the work will go as patent and some of them will go. So Asta, the software name is, I require Rajeshwari to type back in the chat box, Gem5, Sniper, and then Chamsin, Tejas. These are simulators that is used in architectural tools. Okay. Any other question from anyone? So there is a question from Akshit Kapoor. What is the relation between compiler design and loop unrolling? Actually, there is no difference between them. Compiler design is a field of computer engineering where you are coming up with a software which can take a high-level language and translate into machine-level language. That is compiler design. Loop unrolling is a technique, is a sub-portion within compiler optimization. We have something called code optimizer inside a compiler. So compiler has different phases: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. So you generate a native code and then you look at, can you improve the code? So loop unrolling is one such optimization technique that is being done by compiler. So if a loop is unrolled and then the program is being handed over to hardware for fetching and execution, there is always a possibility that hardware can execute in a better way, because I am working with not only with a simple block, I am working with a large set of instructions which give me bandwidth to rearrange. So loop unrolling is a compiler optimization technique, whereas compiler design is a field of engineering, field of computer engineering, which deals with design and construction of compilers. Yes, Shubham, your hand is raised again. Yeah.
Yes, sir. My question is somewhat in line with what Asta asked and your explanation. So, as you said, because this question was I was solving in assignment also. Like as you said, we are currently dealing with suppose one branch history, and suppose we say 1 bit or 2 bit storage we are using for previous means instances of particular branch. So if there are multiple branches which have been executed through a particular process, so it will be internally arranged like a page table kind of a thing.
Yeah, no,
which
if
will
you look at the branch history table, the first branch will have 4 rows. Let us say I'm talking about last 2 branches. The first branch is dependent on the last 2 outcomes of its. So in that case, how it happen? Last 2 outcomes can have 4 possibility: NN, NT,
Yes, yes.
TN, and TT. So that will give you four rows in the branch. So the first branch will take 4 entries in the branch history table. The second branch will take another 4 entries in the branch history table. So then you can increase.
Yes.
So based upon which branch you are kind of indexing into that row.
Yeah. Basically, it will be like as you said. Suppose 4 instances have occurred for first branch, then there is a second branch for which 3 instances are there. So if second branch I am choosing, I have to go to the 3 sets which is stored separately.
Shubham, it is not like that. Okay. So let me try to explain. Do you know which is the branch predictor slide number? Someone can tell me quickly. So 3 is unearned, maybe 2 is. There was a tutorial. I think it will be 2F. Yes. So let me share my screen to make it. This branch predictor is one of the challenging topics. So if you try to learn it, and it's always good. Can you see my slide?
Yes, sir.
Okay.
It is visible.
So this is a case of a single branch. This is part of 2F, the tutorial. So if I am taking this tutorial question, can you see this? I am talking about a single static branch.
Yes.
Which has 16 times it is going to run. So it is a 1-2 type. So 1-2 type means I look into last occurrence of the branch only. So based on last occurrence of branch, last occurrence can be taken, last occurrence can be not taken. Okay, what this 2 indicates? It is a 2-bit predictor. Now let us look into the branch. See, the branch, this is the 1 row is just your branch history table. What you see in the slide is not your branch history table. Only 1 row is branch history table. What I am demonstrating is how the branch history table changes over time. So this one row, your serial number 1 that you see, and the third column, BHT, that is only your branch history table. Branch history table has now 2 rows. First row contain a value called 00. Second row contain a value called 11. Now, I refer to the first row, that is 00, which is given in red color. After this branch, that 00 will become 01. So I am just showing how the branch history table changes over a period of time. This doesn't mean that the branch table has 16 entries. Okay. Branch history table only has 2 entries. Why 2 entries? Because it is a 1-2 type predictor. 1-2 type means I look into the last outcome. Last outcome, if it is N, I refer into the first row. If the last outcome is T, I refer into the second row. There are only 2 rows in this branch history table.
Okay.
So what you see in the slide is not branch history table. It is the demonstration of how the contents of branch history table changes over a period of time. Okay.
Yes. Yes.
Now, if there are 2 branches, then what happens? You may have 4 rows. First 2 rows would be of branch 1. Next 2 rows would be of branch 2. Okay. Now, this is an example. In the same 2F, this is an example of 2-2 type predictor. 2-2 means I am looking at the last 2 outcomes. Okay. The last 2 outcomes of the same branch. So, the last 2 outcomes can be NN, NT, TN, and TT. That means there are 4 possibilities. So my branch history table has 4 rows. First row is 00, second row is 00, third row is 11, fourth row is 11. That's all. Now over a period of time, these values changes. So the question is about at the end of all 8 iterations, what is the content of branch history table? If you look at the bottommost column, sorry, bottommost row, then what you see is that you are seeing this. Okay. The bottommost row is 1, 1. So the first row, which was initially 0, 0, now it became 1, 1. Correct? Then the first row, which was initially 0, 0, it became 0, 1. That is second row. Third row, which was initially 1, 1, it became 1, 0. That is the answer for it.
Yeah, understood. Now it is clear.
Okay. So I am just demonstrating how things move over a period of time. For each iteration, how it changes.
Yeah, earlier while going through these slides, I thought that it is a software's kind of a
No.
table.
It is just a 4 entry or 2 entry small buffer.
Understood. Yeah. And it changes as the execution happens.
Yeah.
Yeah. Clear. Thank you.
So there is a question from Chirag. He's asking, Chirag is a 5th semester Dept of CSE student. Can you please guide to how to pursue a career in architecture and design? So Chirag, one thing is if you wanted to pursue architecture and design, you may have to understand architecture as a subject very well, familiarize with some of these tools, and take up your final year project on this. If any help is required, we will be happy to offer you the help. And then you come up with, work with the simulator and then try to modify changes, implement some of the existing papers, and then try suggestion. And then there are plenty of conferences wherein students can come and visit. And that's a place where Intel, AMD, NVIDIA, all these companies also will have its own presence. They sponsor a lot of money. They will be the prime sponsors of this conference because they find the talents in these venues. So I have seen it across over the years. They come and then try to look at what the students are presenting, their poster, and then ultimately landing up in these companies and pursuing their career. The other aspect is if you look at a broader perspective, if you wanted to be known as one of the best computer architects in the country or top 10 computer architects, then go for a master's program, come and join PhD in some IITs and continue as a faculty of IIT so that you can float then your own NPTEL courses down the line where more people will learn about it. So there is an academic way that you continue. There is an industry way that you continue. If you wanted to continue in academics, you can help lot many people. If you wanted to pursue in industry, you can learn. At the same time, you can contribute to products. So I consider my products as my students. When they find passion in computer architecture, that is my product. Okay. So I am trying to invest my time on students or people like you who find some interest because of the course. So people generally have a fear of this course. But then over a period of time, if you systematically put time on this course, you find architecture interesting. The difference is there are, let us say, 10 jobs in the industry for architecture, only 15 people will compete. But if there are 100 jobs in AI or ML, 1 lakh people are competing. That is the difference. So there is more number of jobs in AI ML market, but the number of competitors are also multiple times, 4 order, 5 order magnitude. The number of jobs in the systems domain, especially architecture, operating systems and networks, the number of jobs would be little more less than what you have in AI and ML, because AI ML jobs, even a small startup can start. But if you wanted to work in semiconductor domain, it requires $1 billion than investment. So big companies will invest and they are looking forward for talent. If you do well, I can take you as a summer intern in 2025. For 2 months, you can be in my lab.
Sir, I would absolutely love that.
Okay, Chirag. Okay, so do well for the exam. Let me see.
Okay,
The
sir.
exams are very simple. Okay.
I'm preparing, but related to exam, I had a doubt. Like we have cache memory questions, and those are quite typical in nature. So will they be coming in exams?
Exams, there will be simple questions which everybody can answer. There will be some questions which only some of you can answer. There will be a bunch of few questions where I don't want any one of you to answer. Maybe at the end of exam, you will go back and then you sit for 1 hour, you will be able to get it. Okay. So ultimately, you will be able to find solutions for even tougher one. It's all up to how to apply mind. So up to 80 to 85, going through the course is good enough. If you're targeting more than 85, little extra reading is required. Cache memory level, numerical questions will come for exam with higher marks, more marks.
Okay.
So Asthas when questions, when we run this program for the second time, even the first iteration will have some history to refer. First iteration don't have any history. First iteration always start with initial case of either N or NN. So how many of you are seriously preparing for exam? These are few tips. Exams, go through the assignments very well. Look at the assignment question, detailed solutions are given. 60% of mark would be from assignment type questions only. So if you know how to solve all the assignment questions once again, that will easily give you 60 plus, 60 plus. Okay, little twisted in assignments. So I will check whether you understood the assignment really well. That is another 30 questions. And 10 questions would be of little difficult level, but last time there were close to 25 students who got more than 85. And 6 or 7 of them I gave chance to work with me as interns. And now they are working in Jump 5. Some of them are from IIT, some are from Chandigarh University, some are from PSG, Coimbatore, various universities. And now they are working with my PhD scholars. So we will open up a lot of opportunities for students who are doing well. So please do spend time on assignments after the solutions are displayed. Detailed solutions are being given. Go through it. They are sufficient enough to solve it. And every week there is a tutorial session with little emphasis given to numerical problem solving. Watch them multiple times. Try to understand, because by hearting also you can answer some of the questions in every week, because it's less like a fill in the blanks or multiple choice. The last 1 or 2 questions every week, if you are able to solve it by yourself, you are studying very well. Any other questions or any query from anyone? Yes, Shubham.
Sir, I wanted to know, any resources you suggest, like any sites which which are in line with whatever we are studying, like
No,
from
there
a
are topics.
from a
There are topics, this up to cache memory, up to DRAM, and up to pipeline. Hennessy and Patterson's textbook. Even you can visit the website of Professor Hennessy and Patterson. They are world-renowned computer architects. Lot many slides, animations, everything that has been given. Reading textbook is what is missing in the new generation. Probably with over digital devices, textbook reading is no longer fancy, but textbooks is like Hennessy and Patterson is the ultimate wisdom in this field. So if you look at videos and make it easy to understand, you miss many things. You will have only a superficial learning. But textbook reading takes time. That's how knowledge base is built. Okay, if you wanted to know, because what you know gives you a career. Because the rest of the people don't know and you know, that makes a difference, whatever be the field.
Yes, yes.
So that comes only with patient, slowly, brick by brick building of reading world-known textbooks. And there are plenty of numerical problems at the end of the textbook. Solution set of these numerical problems are already available. Look at that and then try to understand your reasoning. Please do understand that the course is multi-core computer architecture. It is not an elementary computer architecture that has been covered in an undergraduate course. So once you get that upper hand, you are much above many of the students who don't get a chance to learn courses like this. Okay, we do have a lot many people from industry who are regularly taking this course. Freshers joining in these companies, they also give us feedback. Sir, we just joined in this company. First 2 months we are in learning. We are learning your course. Our senior managers then recommended going through this course. So it is very much an industry relevant. And India going to become a semiconductor hub with a lot of fabulous, and then that's going to come up in the 1 or 2 years. There will be a lot of demand for people with architectural knowledge. Yes, Chirag.
Sir, there's a little time left. So can you talk about a little about tensor cores and RT cores, which are used for like tensor cores are for artificial intelligence and RT cores for like ray tracing and all.
Okay. So, Chirag, these are specialized programs. Okay. Programs which run AI or ML workloads. The peculiarity of these programs is these programs heavily do certain operations multiple times. It involves neural network processing, which is a typical AI or ML program means it has a collection of neurons which will multiply and input with a weight. So essentially in hardware, these are multiply and add operations. So we require a lot of MAC units, multiply and add units. So we will have a session which is called domain specific accelerator, which will come in the 12th week or 11th week, where we talk about this kind of processors. What is the difference between a general purpose processor and an AI processor? So AI processor, it does same kind of activity for a large data. Let us say I wanted to perform a multiplication of two matrices, 10,000 by 10,000, 10,000 row and 10,000 column. If I have only one adder, then I can do it one by one. So it takes a lot of time to complete adding. So if I have not many add and multiply units, then matrix multiplication and adding becomes easy. So in short, AI and ML workloads consist of a lot of matrix operation. So can I have a hardware which will make matrix operations quicker? That is essentially the heart of AI processors or tensor core processors. I will talk about it in the 11th week, once the interconnect is over. So we will meet in September also once like this, and October also, 2 more live sessions. Please do interact with in the discussion forum and enjoy the course. Don't wait for Monday or Wednesday evening to complete that. Plan in such a way that by Monday itself you are completing. Because last moment when you try to finish up assignments, you will look only the questions and you try to look at the video which will help in solving the questions. You should not see the questions at all till Monday. Complete the videos of the week, tutorials, and then start questions. Don't look at assignment questions before looking at the video. Then you become biased. You're always searching for the answer of these questions. What if I give a different set of questions for exam? So please do understand it's not assignment that is important. It is the videos and the tutorials are important. The other one is just checking your skill, whether you understood or not. Okay, so I think we have covered all the questions. Now it's time. Sir, this one, okay, this is the second live session. So we have third and fourth live session. If at all we want more, we can have one more live session. There is no problem. So it is mandated from NPTEL to have 2-3 live sessions with a recorded one. If it is not recorded one, we can have live session any day evening. Okay. So I assume that there are no more questions. If anyone wanted to speak, your last 5 minutes to speak, or else we will end the show. Great. Okay, so then thank you once again to all of you who have come for this program, and special thanks to my backend team, Rajeshwari, Abir, and Vivekananda, who have been going through preparation of assignments and answering your questions in consultation with me. And don't get so discouraged even if subsequent weeks are tough. Some of the weeks may be tough, but then learning the toughness is what you have opted for. And once you cross the toughness, there is a lot of demand for such people in the industry. So never get so discouraged. Whatever happens, go and write. Closer to exam, I'll give you more tips how to plan. Still, I have not prepared the question paper. So after that, I can give you more tips. So don't think about the exams much. Ultimately, people who are going to interview you or discussing you will get to know you understand hardware. Thank you very much for all of you joining. Thanks to my backend team, all the 3 PhD scholars. We'll see you in the next live session. Enjoy learning this course. Thank you.
Thank you, sir. Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.